So the second type of t-test that we're going to do is the paired sample t-test. And so before we did the independent sample t-test where we had two groups, but they were two completely unrelated groups, two different, people in each group. There's nobody who was in group one that was in group two. There was no relationship. But in this case now, we're looking at the paired sample t-test, and this the most common use of this test is the before and after test. So now we're comparing the difference in mean, but it's the same group, right? So we have a group, they were supposed to be evaluating some intervention. First we test them, the null value, or we test the before measurements, record those, and then we do it after the intervention and record those values. So here we have, in this case, this is another one of SPSS sample data set, and it is some task that the subjects are performing, right? So we have a group of 10 subjects, and they're performing task one, task two, task three, task four. So if we were to say task one is like the control. That's the task they perform before the intervention, before anything happens. This is the task. This is the measure of their performance. And then task two is when after the intervention or sometime later after something has happened, and we want to see if there has been a change and if the change is statistically significant. And that is where we would use the paired sample t-test, right? Pairing meaning that there are a pair of measures that we're going to be looking at, and each pair corresponds to one subject, right? Each subject, there are a pair of values, and we're going to evaluate whether there is a statistically significant difference between those two groups. So that's what we use the paired sample t-test for. So again, we go to the Analyze tab, comparison of means again, but this time we're doing a paired sample. And so this is what it would look like. So this is how we would be evaluating our paired samples. So we would put the first measure in there and the second measure here. And so that's all we're going to be doing at this point. There's more to these tests that we can do, but we're just going to be looking at just the before and after in this case. And so we do okay, and we have our results. So when you have something like this come up, that means the output is somewhere, but it's hidden. So you go up to the Windows tab, and you can select the output window. So this is what our paired sample t-test would look like. So I can go in here and I can edit this, and that would be that. We can then you know change the font and the color, so that sometimes when you're running these tests, you're going to have a lot of stuff accumulating, and you want to know where to go to find stuff when you're ready, because you can save these files and open them up again at some later date. So here we have our paired sample t-tests on a memory task of sort, right? And we had 10 subjects, and they each had a before and after score. So the average score for the subjects was 6.6 for task one, or the pre-task or the pre-test. And then the average score for the post-task is 6.5. Now that is different. So we see that there is a difference. But what we need to know is, based on the distribution, based on the variance in each of these groups, would this difference qualify as being statistically significant? So we see here 6.5, 6.6, and 6.5 for each of those values. And there is a correlation between these two measures of about 6.73, right? So that is in terms of how much related these two values are. So there's a 6.73 correlation between each of those values, and that correlation is statistically significant, right? Because we see that it has a p-value associated with it of 0.033, which is less than 0.05. And so we're going to say that the correlation is statistically significant. But of course, we expected that, right? Because these are the same people that we're measuring, from task one to task two. It's the exact same group. So we now go to our paired sample t-test results. So the third table is the one that we're interested in. And this is the value that is key. This is our p-value right here at the end. And this value is what we evaluate compared to our critical value to tell us whether there is a statistical significance or not. So just like when we do manual calculation or conversion, we convert the values to either a z-score or a t-score, depending on whether the distribution is normal or not, or whether depending on the size of this group. So you notice here the size is just 10. It's a small group, so we're using the t-score here, and we get a t-score of 0.218, and that t-score has a statistical significance value of 0.832. And so we are going to determine that this difference of zero point 0.1, remember 6.6 minus 6.5 is 0.1. This difference has a statistical significance of 0.832. What that is saying is, if the null were true, meaning if there were no difference between the two groups, statistically significant difference, then there is a very high likelihood, a 0.832 likelihood that we would get such a results, right? And it's a small difference, just zero point 0.1. So the likelihood of getting that difference is actually quite high. And so that's why, because it's high now, we have to reject our, sorry, we cannot reject our null hypothesis in this case, that the difference is. So the null hypothesis states that there is no statistical significance, and based on the evidence, it appears to be true that there is no statistical significant difference, because this difference here has a very high likelihood it can happen for a number of reasons just randomly if there were no real difference between the values. So we see here between task one and task two, there's no change, there's nothing happening, there's no statistically significant difference, and so that's how we would report that.